Okay, so moving on to lesson 6, we're now applying the Newton's law of motion. So it will kind of tie into all three laws, law 1, 2, and 3. So the first one is when things are, we call it object in equilibrium, meaning when the net force is 0. Okay, and in that case, it's not accelerated. And so wordings that you'll be looking for, we already talked about that. If something that is not accelerating, it has two implications, right? It's either traveling at a constant velocity or that is not moving. And if that's the case, you're actually still trying to find the F net, but F net equals to 0, right? So that's kind of where this is getting at. And we're going in a slope. We already talked about how to draw a free body diagram. So let's read this question. This is something new for you that you haven't really done it before. So we're going to go through this step at a time. The sled has a mass of 14 kilograms and it's on an incline at 25 degrees to the horizontal. So do you see this angle? 25 from the horizontal. The hill is very icy, so they're asking you to neglect friction. So there's no friction. And they tell you that it is at rest, hold by a rope that is attached to a post. So we're going to be dealing with force of tension. Calculate the magnitude of the tension in the rope and calculate the magnitude of the normal force. I'm going to draw the picture bigger just to make sure that we're good with the angles and stuff because we haven't really done it before. I want you to have a clear picture. So I'm going to draw it quite big. I'm going to try to be more neat and see if I can do lines, okay? So this is the slope, okay? And I have a box. I don't know how to draw a box on an angle. I'm just gonna not do a box. Okay, maybe I'll do a box. Let's try. Make it bigger. Oops. Make it bigger. Turn it on an angle. Oh, okay, not too bad, not too bad. So I got a box sitting on the slope. Okay, forces that are acting on it, hopefully you guys get this. I need the line to have an arrow. It ends with an arrow. Let's do this. Okay. The force that we're going to have is force of gravity that's coming downwards. Are you guys so far? Okay, I don't like this guy. I don't need this guy. Okay, and then we talked about force of normal is 90 degrees to the surface. So force of normal should be going up this way at a 90 degree. So this is Fg with an arrow. This is Fn with an arrow. They tell you that this angle is 25. Okay. Every time when you're doing question like that, you will turn your axes. You will actually keep your x and y going this way. Because you don't want your acceleration. I know this object is not moving, but if it's sliding, you don't want your acceleration to be in component. Okay, so we're almost tilting the picture. So that means Fn is completely going along the y direction, but do you see how Fg is partly x and partly y? So what you will need to do is you actually need to break your Fg into component. You're going to have to draw your Fg going this way to form a right angle triangle. And take a look at the red triangle and take a look at this 25. Okay, common sense, why with the way the picture looks, can you tell me which angle? Is it the top one or the bottom one that is 25? Which one looks 25 to you? Okay, I need you to keep in mind that this angle is always the same angle as your inclined plane. If you want to study using the triangle theorem, you could. Like you can totally draw like right angle triangle and prove to yourself that it is 25. So at this point, I'm just going to say the top angle is 25. And then with that said, then now I can split up the x and y component of the Fg. So the side that is on the right hand side, so I'm doing this guy now, okay, this guy right here, okay, that is adjacent. So this is Fg cosine of theta, and this is Fg sine theta. Okay, so now that I've generated the Fn, the Fg, don't forget that it still have this rope right here that we would have to draw another force vector. I don't know how to raise it. That is called the Ft because that's a force of tension. I'm having these arrows flying everywhere. I'm just going to delete them. Okay, I don't know how to delete. Okay, so now that I've gotten all the forces, I can now analyze them along x and along y. So all the forces along x. So don't forget your x-axis right now is this way. This is your x-axis, right? So forces that are along x, there are two forces. I'm going to have Ft and then this guy that is going along kind of the downward x direction. So net force along x, we would go forward minus backwards. Which one is your forward? Forward is always the bigger one, but in here we already talked about this is the first law question, so it really doesn't matter which one is your forward. So I am going to pick the Fg sine theta to be my forward. So I'm going to write Fg sine theta minus my Ft equals to ma. You always start out with F net equals ma. And then because we said the acceleration is 0, because it is at rest, so there is no acceleration, this is 0, I can say that I can now take this and I can rearrange the equation and solve for this. So the first thing we need to do is Fg. We talked about it yesterday. Fg is m times g sine of theta minus Ft equals to 0. Move the Ft to the other side, it becomes a positive. I have m g sine of 25. Punch it in your calculator. Your Ft is 14 times 9.8 times sine of 25. So my Ft worked out to be 58 newtons. The direction of Ft is backwards 25 degrees up. Okay. Now that we've done that, we're now going to analyze it along the y, because the y direction is where the force of normal is. Take a look at the forces again. Okay, forces that are along y, I have this one and this one, right? I got two forces that are going along y. What are the net forces along y? I'm going to go up minus down. Up is Fn, minus down is the Fg cos theta equals to ma, and because I know a is 0, I'm going to use this to solve for what my Fn is. So Fn is going to equal to, I'm going to bring my Fg cos theta to the other side. I'm going to take this and I'm going to make it over there to make it a positive. So this is Fg cos theta, and since I know that Fg is m times g, so F is 14, G is 9.8, cosine of 25. I got something like a 124, so I need two significant digits, so 120 Newton. Okay, and the direction for this is going to be up 25 degrees forward if you want to be specific. I know this one's hard to name. All right, let's see if there's another. Okay. Let's go to question 2. Your car is stuck in the mud, and your friend suggested that you make a knot in the middle of the rope, tying the other end of the rope to the tree, and then you pull on the net. Leave one end of the rope attached to the car and tie to the other end at an angle of 10. Then you and your friend pull on the knot in a direction indicating at 1,000 newtons. So this is how strong you and your friend is. You and your friends are able to pull at 1,000. So this is 1,000. Okay, you discover that you're able to free the car at a slow, constant velocity. Okay, implication from the question, constant velocity, meaning this is a first law question again. The acceleration is 0. How does this work? So basically, they're trying to ask you to say, you know what, you can actually gain mechanical advantages if you actually take one strain and then you tie it to 2 and make it stronger. So they basically want you to calculate what is Ft. And because Ft is the same string, you see how this string and this string are the same string, you can assume that the Ft is the same. So we've been talking about the third law. Whenever it's the same rope, it is the same length. Okay, so draw your free body diagram. We're going to draw it at the knot. I know that this is FA that is pulling downward, and I know that is 1000 Newton. Okay, so that's where this is. Okay, I have FT and I have FT, because we always study the forces at the point is always along the rope away from the point, right? So I got the two FT. I'm not even going to label it left and right. They're the same value, so I'm not going to introduce another variable. Okay, and then with this, they tell you that the angle is 10 degrees on both sides. And they basically want you to calculate what is FT on the rope, and then compare it to the 1000 newtons that you're able to pull, and then see how it got stronger. Okay, so let's break them into X and Y. So how you set your X and Y is you want to make it easy for you. So this one is a regular, like I'm going to set up my XY axis the normal way because I'm not on an inclined plane. So break up your FT into the X and Y component and break up your FT along the X and Y direction. Okay, so hypotenuse is your FT. And so if I'm supposed to do this side, okay, I have opposite to the 10 degrees, so the component is going to be FT times the sine of 10 degrees. Okay, the one that's at the bottom, the X, the along X, is going to be FT cosine of 10. So we're just breaking these things up into component. I'm going to do the same thing with the green lines. Okay, so on the Y along, it is FT sine 10 because it is opposite to the 10 degrees. And then this one is FT cosine of 10. Okay, so now that I've gotten all the forces, I also know the acceleration is 0. So I'm going to go F net equals ma, but a is 0. Studying along X or Y. So let's just study it along Y, because X I just have a force to the left and a force to the right, and they look exactly the same, so it becomes 0. So I'm just going to study the forces along Y. Okay, what are all the forces along Y? Okay, I have 3 forces in total. I'm just going to highlight this. 3 forces in total. I got one that's going up, another one that's going up, and one that's going down. So I'm going to go up minus down. What are all the forces that are going upwards? I have FT sine of 10 adding FT sine of 10. You can say 2 FT sine 10 if you want. They're exactly the same. Minus the down, which is the one I should use the variable, which is the FA equals to MA. Always write up F net equals MA. Okay, then from here, you now solve for your FT. I know A is 0. This is a part that people sometimes forget, right? So if along X and Y, there's always at least one of them that are 0, sometimes both. Okay, so clean this up. I am going to move my FA to the other side. So I'm going to have a positive FA, which is 1000. And then I'm going to look at these two. And I know that there are 2 of them. So I'm going to go 2 FT sine of 10. And then I'm going to take my 2 divided on the other side and the sine of 10 over to the other side. This is the part I would like you to punch it in the calculator. I do find that sometimes people have a hard time how to punch this in. Can you punch it in first? Pause the video, punch it in the calculator, get an answer for me. And I'm going to tell you how I got it. How I got to. Okay, I got the answer to be 2879. Did you get that? I haven't put it in the correct technique yet. I will do it. Okay, this is what I got. So be careful. I have people, when they punch it in the calculator, this is just a side note. Most of you should be good, but just a little reinforcing. Okay, you can go 1000 divided by 2. Do you, on your calculator, do you then do divided by sine 10 or multiply by sine 10? So to punch it in the calculator, you go 1000 divided by 2 divided by sine 10. Some people would look at the right here and say that that's a multiply, and they would go 1000 divided by 2 times the sine of 10. If you are doing this times, what you've done is you've moved this up to the top. If you want to do the times, you have to put a bracket around them because there's an invisible bracket when they are doing the denominator, right? Every time numerator and denominator, there's a hidden bracket in there, right? So you would be dividing. Make sure you divide. The answer should be 2879. So I rounded to the correct sig. There's 2 significant digits in this question. So I'm going to round the answer to 2900 Newton. And the forces of tangent, you don't know left or right. So if there's more, if anything with the direction has more than 2, you don't write the direction. Don't worry about it. Just leave it. Okay, so how does it work? Take a look at it. By just tying it on a rope, even though the guy are still pulling it at 1000 Newton, what I've done now is, look how much stronger the forces that's acting on the car is now. It's called mechanical advantages. That's why pulleys and all those stuff work. We're not really going to cover it in this class, but with just turning one rope into 2, if you can turn it into more strand, it would even become stronger. Okay, the force of tension that's now pulling on this rope is even stronger. Okay, so we've done first law. Tricky thing is break things into the XY component. Try to set up your coordinate that your acceleration is never going at in 2 directions. So now moving on, it's how about if it's a second law question? Okay, object is accelerating. F net is equals to ma. So it is accelerating in some direction. The net force is not 0. So let's study this. Same question, similar question to number 1. The picture looks more confusing with all those stuff. They give you the angle at 18. I think some of my setting is wrong. Okay, it's at the top, and the height of the hill is 25. So you see that this is 25. Calculate the speed of the sled as it reaches the bottom of the hill, assuming no friction. They want to speed. Oh, they're actually joining it with kinematics. So with these types of questions, you're going to have to, first of all, use forces, find out what the acceleration is, and then deal with it with the kinematics, which is the high five. Okay, so you draw your free body diagram on an angle. I'm going to draw it a little bit bigger. Okay, they had your slide backwards. So I have my FG going down, my FN going up this way, and this time there is no rope. I don't have a rope holding it down, so I don't have the FT. Okay, we said that we always set, if my acceleration of the sled would be down the slope, then we would set our XY axes when it is lining up with the A, so that I'm not breaking up A component X, A component Y. We're actually trying to just break other things into component. So with these types of question, we call these the inclined plane question. You might want to write it down. These are called the inclined plane question because you're gonna hate me later on when we go into centripetal motion, things going in a bank curve. We're dealing with slope again, but these type, when an object is sliding on an inclined plane, we would always break the FG into component. So you might want to make a little star just to write that down. Okay, so let's break FG into component. So FG is going down, so lining up with the FN, I'm just going to draw a down and then going forward. The angle they gave us is 18. Where does 18 fit inside this triangle of FG? We talked about that just now. This angle is 18. Okay, the angle at the top is 18 degrees. Okay, I'm just going to change the color because it's hard to see. Alright, so I'm just going to change it into a darker color. So this one is 18 degrees. I'm not making it any better. This is 18. Okay. Alright, so break your FG into component. So 18, so this guy is opposite to the 18 degrees. So it is the sine. Okay, the one that is on the side now. This one is beside the 18, so this one is FG cosine of theta. So break them into component. It might look complicated the first time, but you would realize that it's almost the same thing every single time. All right, so some of my forces along X, some of my forces along Y. So along X, I have one forces only. Okay, Fg sine theta, this is the only force that is along X, right? I don't have any other forces that are going along X. So Fx, studying the forces along X, my net force is forward minus backward, I have nothing backward, equals to MA. And Fg sine theta equals to MA. I know Fg is mg. Sine theta equals to MA. I actually think I have enough information to solve for my M. Tricky. The question did not give you mass. But do you need mass? Okay, do you see how I have M in this term and an M in this term? Whenever I have the same variable in every single term, there's only two terms in this question. Like if I have something like I'm just making this up. If I have like a plus 5, you can't cancel your M because the M is not in here. But in this case, both terms both have the X, the M, I'm allowed to cancel it. So this guy and this guy is gone. So I now have 9.8 times sine of 18. It equals to the acceleration. So 9.8 times sine of 18. I got 3.0 meters per second square forward, 18 degrees down. Okay, that's my acceleration. And so what happened is I've already calculated the acceleration, and that's what I need because I now need to find what is the speed at the bottom. So I'm going to start my data list again. There are certain assumptions with it. I would like to know at the bottom what is V2. That's what I'm looking for. I now have found that the acceleration is 3.0 times 10 to the meter square. And there's always assumption. I don't know if they mentioned it, but the assumption is that you start off at 0 at the top of the hill. The only thing that I do not have is a delta D that I'm able to find. I don't have the time. It didn't say anything about the time, but I can figure out the D. And this one, you have to use a triangle again. The D is along the slope how far I have to go, right? This is the D that I need. They gave you an equation already, but you can just basically is telling you to just use components. Like if I have Pythagorean theorem, the cosine law. Okay, I have a 90 degree. I know the height is 25 meters. If I am looking for this, if this is my delta D, and I know that this angle is 18, do you see that I can just use my triangle? So they just rearrange the equation as h times sine. If you were to do it on your own, you know that this is 18, so I have opposite and hypotenuse. So this is my sine again. So sine of 18 is opposite over hypotenuse. Solve for hypotenuse. When the unknown is at the bottom, you can just swap it and it equals to 25 times sine of theta. So if you want to work that out, 25. So I'm just going to write this down, 25 times sine of theta. So now you find the equation. I have V2, A, V1, and D. Now you're going to pick out your high five. Which equation works for your high five? Okay, so hopefully you pick this one out. So V2 squared is equals to V1 squared, which is a 0. So this term is gone. 2A delta D. Okay, so I'm just going to punch it in the calculator. So I got an answer of 490, and then I have to take the square root. So V2, final velocity at the bottom of the hill, is 22 meters per second, forward 18 degrees down. Okay, so this is the part that we're talking about. Sometimes second law, it will tie into kinematics. There are assumptions, right? V1 is 0. On the question, it also assumes that there is no frictions. When it gets to friction, then we will have an extra force that we will